I seem to find new ones every year, so maybe when I've done this 20 years in a row, I'll finally have clean slides. So don't be shy about questions because typos do creep up. So for our lab, we're going to use the data set that you already have open, and we're going to recode 3 different categorical variables. The first one is school type. And this codes whether students attended a public school or a private school in this particular study. And what I want you to do is make public schools the reference group. So what are we going to name that variable? Private. Yeah, okay, I heard. Yeah, because we want the 0 to represent public schools. So we're going to call the variable private. For SES, there's actually 3 levels to it. I want you to create 2 variables, but with middle SES as the reference group, okay? And then finally, there's a race variable, and if you look at the descriptives for it, even though this is a random sample of 200 students from the larger study, and they oversampled different populations in order to draw stronger inferences, the random sample actually got some pretty small sample sizes for some of the different race and ethnicity categories. So what I'm going to ask that you do is take this multi-category variable and turn it into a single dichotomous dummy variable that compares white students to all the other students. So it's all the other students who are the reference group here. Okay? And you're going to want to save this file because we're going to be using it not only later in tonight's class, but also repeatedly in the weeks to come. Okay? In lieu of uploading a Word document, I know that connectivity is a problem today, so sometime over the course of tonight or tomorrow, just upload your log file, the output from doing all of this. And it should include your log and also your frequency results, your check for whether you coded things correctly. Don't bother with the brief explanation because I already explained it to you. Just be spitting it back at me. But if you want to take notes, it's good. Yes? Michelle. Oh, the log. Okay, so it's the .spv file, isn't it? Yeah. Sorry, that's like leftover from when I learned stats where I was working with SAS and literally the files ended in .log, so my bad. Good point. Yeah. You can do small groups, or you can work individually, whatever makes you happy. Okay? Good. So go for it, and we'll probably won't take that long for this one, probably 15, 20 minutes, so raise your hand if you're lost. All right.
I needed to re-download SPSS, and since the internet is not on,
I
can't
okay.
do it. So
Oh yeah, just pair up. That's fine, and then just send her a copy of the file when you're done.
when I have the internet.
Oh right, yeah, later.
Yeah.
So Elisa, and don't tell me. This is going to take me a minute. Jessica, okay. Did you take Stats 1 with me? No, okay. You seem familiar. Okay, all right. So you just did it last year? Okay.
That's not the verb for taking action.
I'm not sure if that's going to work.
I didn't check to see what the
Yeah.
original values are, and so I just wanted to check that.
Yeah, oh no, that's fine. So you can cancel out of there. I don't think it's going to work to do the two at the same time because the let me pull gender out. That's all you need to do. Sorry. So cancel, click that, and then pull that in. There you go. Okay.
I see. Okay.
Mhm.
So you can only have one in here.
I think so. I haven't figured out how to do more than one appropriately.
That makes sense. When you talk about this log, the log file, is that like a save as thing? I've never had.
No, you can just save it.
Oh, the whole file? You don't want me to upload this whole thing, though.
No. You would save this.
Oh. Huh, just that little guy.
Mm-hmm.
Thank you.
Yep.
What does SES stand for?
Socioeconomic status.
So we have high, middle, low. We're just trying to think of what we're going to recode it into the name. So what would you name middle?
Well, first of all, we want middle to be the reference group, right?
Correct.
So we need to indicate the other groups, right? So, right?
High or something, or not
High or low?
Yeah, exactly. So what I might do is call one low SES and call one high SES. One other thing, though, is you want to pull gender back out.
Okay.
And you probably want to do these one at a time because it's going to use one recoding scheme for whatever you put in there.
Okay. So once that's done, just
Mm-hmm.
Okay.
So you're going to have to do two variables.
Yes.
So you're going to have to do this twice. That's why, well, all right, let's think this one through and then we'll talk about syntax. So if we want middle SES to be the reference group, it's like our placebo, right? Then we want one variable indicating low SES and one indicating high, right? So is high going to tell you what that really means? Go back for a second. I'd put high SES because otherwise you're going to forget in the label. Okay. So, yep.
So we want 2 to be 0.
You got to say, oops, where'd it go? I find this interface really annoying too. You got to say add.
Yeah. And then we want 3 to be 1. And then is 1 going to stay 1?
What's going on? It's freaking out. Huh. Oh, do you have a space in there or something? Hold on.
Space up here.
Wait, say cancel. Oh, cool. All right. It's already in there. Weird.
zero. That one goes in just fine.
Huh.
Never seen this happen.
I think you broke it.
All right, so say continue and then okay. Say okay. And then let me try something here. I'm gonna do this. And that's really odd. Let's see if I do one. So I'm making. What the hell?
Yeah, I did something bad.
I don't know. No.
It is pretty good.
All right, that's really odd. Do you want to try it with yours?
Sure.
Yeah, pull the other variable in. Sorry. Did you already do the other one? You did private?
Yes.
Okay, great. Perfect. You can't have a space in a variable name, but you can in the label. You know what? Try doing low SES. I don't know that makes any difference, but it shouldn't. Oh. That's weird. Okay. Okay. And so what should we do with the 1?
One we could, so we could leave that the same.
What does 1 represent in the current variable?
The low SES.
So if we leave them as 1, then we're saying they're high SES now. So it helps to see, to actually do a table like we had. Mm-hmm. So the original variable is 1, 2, 3 for low, mid, high. And so for a high SES variable, we want those guys to have 1s and those guys to have 0s.
That's my fault. Yep.
No, it's all right. That's why we're doing a lab. So you did all the old and new, so you just say okay now. Well, except that you lost your high SES kids. So let's go back into transform. And here's the kind of cool thing. If you mess it up, you can use this same thing. Just go to old new values. So you recoded your 1s and your 2s, but you didn't recode your 3s.
So how should you recode them? Like, so is this also going to be...
Yes. Yes. And then you just say, okay. Oh, and you know, the labels are wrong now. If you go to variable view, you need to, fix that because it's actually middle and high right now. So now you're making the low guy?
Oh, no, so I actually went back and was working on the school one.
Oh, wait. Okay. So one thing to keep in mind is that it's going to use those same values. It's going to recode SES if you do that. So before you do school type, what I would recommend is doing low SES.
Okay.
Because then you can use some of the coding that you have in there already. Okay, let me do that.
Oh, so this is what you meant by the syntax. You were just
yeah.
I get it.
Yeah, so, excuse me, so one thing we could have done is we could have pasted the syntax into it. It would open a whole new file. But instead, I'm going to show you how to change it in here. So, in here. So we still want middle to be a reference group, but now we don't want 3 to be 1, we want 1 to be 1, right? Mm-hmm. So change that to 0, and then hit change. And then we want 1. You can just copy the old value, right?
1 to 1. Yep. That's sneaky.
Ta-da! Okay. All right, so then say continue and OK, and then you just need to do it one more time for private school. Just pull the SES out of there. Did it work this time?
I think so.
Yay! All right, we just weirded it out somehow. Okay, so now just do your frequencies to make sure everything went all right. Yep.
I'm having trouble knowing how to label these.
Right. So a 1 is low SES, right? And a 0 is not, right? Or you could call it middle and high, right?
Okay, or like everyone else, or?
Yeah, I mean, you could call it just not low SES, or you can call it middle and high SES.
Okay, so it doesn't need to be.
I'm not missing something there.
No.
Okay.
Uh-huh. Help, help, help. Help. Yep, that's all right. Yes.
So when we're recoding for SES,
Uh-huh.
the low and the high, if we recode, so middle is the reference, middle is 0,
Yep.
and then low is 1 is 1.
Uh-huh.
So high, how are we accounting for that? We're just lumping it into not being low?
Yes. Yeah. So the name of the variable will be low SES, and if you have a 1, you're low SES, and if you're a 0, you're not low SES.
Okay, so then the comparison would just basically be whether or not you're low SES compared to whatever else.
Yeah, if that's all we put into an equation, but what you'll see is that when we think about SES, we want to think about all the categories, so we're going to put in both of the variables.
And then I'll count the high.
Yeah, and then we'll really be comparing to the middle.
But you have to make sure you have all three of those two.
Exactly.
Wait, so like for example, if middle is the reference group, he said we're creating 2 new variables,
Yep.
one for low and high, but you could technically, if you just wanted to compare middle with everyone else, you could still just have one other variable.
Yeah, if that was your research question.
But that's not what we're.
That's not what I'm going to ask in the next bit. So I'm trying to set you up so you can answer research questions coming down the pike.
I just wanted to know how you'd like us to upload the file and put our names on it.
I think you can just like type at the top of the file. Oh, that's perfect.
So will you? Okay,
Yeah. I mean,
sounds good.
sometimes people put it in the file name. That's fine. I'll find it. Yeah. You're good? Good?
This is all you want is the output, right?
Yeah.
Okay.
Whatever makes sense.
When we run them later, I think it'll be and then we
Forgot that step. We're like, why isn't it here?
yeah. I didn't see my
Well, actually, it's kind of a clue, the name of your variable. You called it private, so the 1 is private.
Oh yeah.
Yep.
Is that right for SES?
So if you make a 1-1 and a 3-1, then you're saying, I want to compare low and high SES kids to middle SES kids. But I want you to, I see, and well, what I said in words but isn't up there is I actually want 2 indicator variables. So I want,
Sorry.
that's okay. So,
We did that. We got low SES as the one grouping and then high SES as the other.
yeah, so this is low versus everybody else.
Uh-huh.
And then,
And how do we get SES back in it to name the
okay,
second?
yeah,
variable?
see, so let me check something here.
Okay.
See, it's got the same codes. You can't do it all in one window. You got to do them one at a time, unless the coding is exactly the same.
Oh, I see. So I should start delete.
Yeah, what I would do is pull this out, because you
I
have
see.
low SES still set up to go.
I see.
So I would run that and then redo it. Yep.
We did that one. Okay. So I have high.
All right, just say continue for a second. Let's pull school type out.
Oh, I already did school type, so I just,
Yeah.
okay.
Okay, now click that again. Click SES. Oh, that's fine. Okay. So which group is high SES out of 1, 2, and 3?
1, 3.
Okay, so only 3 should have a 1. Everyone else should be 0.
So I'm comparing high to everything
Yep.
and low to everything.
Yep.
And middle is whatever's left over.
Yep.
If the variable name is high SES, why are we going to the reference? I would assume that if we're naming it high, it's not the reference group.
Right, it's not. The reference group is going to be middle SES because it's going to be the only group that gets zeros on both of your variables.
So high will be 1.
Yeah.
Low and high might be.
Help?
So
Help?
what do we do with the
When we're changing, we forgot to go back and do our value labels. So since this is where we were interested in low, and so we made the other two, what would we call?
So with this one, it's actually your middle and your high kids, right? So you could call it middle and high, or you could just call it not low.
Okay, thank you.
Mm-hmm. Yep. Oh, poo. Yeah. Yeah. You could just email it to me. Yeah, it's fine. Then you don't have to worry about it. Anyone else still need help? Okay, no, that's fine. Yep, or you could just call it not low. How's it going?
We're using a different problem.
Oh, okay. Oh, right, yeah. How's it look?
No.
Wait, what's wrong?
Shouldn't those be separated out? Like the male and female ones were separated out.
Yeah, something happened. So let's look at your data file, data view. Yeah, they all got zeros. So let's recode it again. Let's do transform different variables. Next one down. There you go. Sorry. That's okay. Okay, and then so. Okay, and then old and new values. See, it whatever you do last is what it remembers.
Oh.
So when you have multiple ones in there, it's recoding every time.
Oh, Lina thought we could do it that way because we asked.
Oh, yeah, no. I better go tell her that. But you know what you can do is you can go to your log file.
Yeah.
Like, we did it so fast. We did it so fast.
Yeah.
Not so much.
Oops, I just messed that up even more. Okay, so let me find your log.
Excuse me, can I follow the sum check?
Yeah, it's right up in the top there. It's a big, long.
I have a hard time to use the April.
Okay. Yep. Let's see here. Let's go to down a little bit.
This one.
No, here, yeah. Here we go. I think you want your original one here. So if I do this, Lina, they can't do more than one in that box at a time. It'll recode the old variable the new way. It doesn't remember them. So let's do a copy, however you copy on a Mac. Okay, and then we're going to do open. Oops. Oh wait, not open. Sorry. New. Come on. Did it not read that? Oh no, it's thinking. Okay. All right, paste. Okay. So now this was the recoding of gender, right?
Mhm.
But actually, this should be male.
Yeah, I screwed that up.
Okay. So let's do that. Because we're going to have to redo everything. Yeah, all the females should become males. Okay, and that one too. Great. Now, let's copy that and paste it again. Okay, so the first thing is school type, SCHTYP. And one is which schools?
Private.
So we want 1 to be 1 and 2 to be 0, and we're going to read into private. Good girl. All right, and then we want to label private. And just kill the frequencies for now. So now you're going to do, well, I'll stay with you. Yep. Perfect. Now paste again. Okay, now we're going to recode SES. And we want, well, let's leave 1, 1, and then, I forget how to do all other values. So do 2 equals 0 and 3 equals 0. You get what we're doing?
Yeah.
Okay, good. And we'll do it into low SES. All right, I'll come back and check in a minute. Don't run it till I say. Did I hear my name invoked? You're okay? All right. Oh, you can't have a space in a variable name, so get rid of that space there. You can have it in the label. That's the label.
Okay, I was just
But you
gonna
can't
get
have
rid
it.
of all of them.
Okay, that's fine. I guess the only thing though is then you might not remember low what. Like if you come back to this in a week, so maybe in the label just put low SES. And then there's not. Tell them to just email it. Yeah, just get rid of one of those SESs.
I know that's wrong, but
Yeah.
I'm like, okay.
Okay, great. Now copy and paste that because that's going to be really similar. We'll just change the lows to highs and fix the coding. So 1 is going to be 0 now. And 3 is going to be 1. High. In some ways this is a little bit faster than doing the Windows stuff. Just replace low. Because you're still going to use SES. That's all right. Okay, and then one more time. Now we're going to do race.
1 and 0.
Oy, which? So you want white to be the reference group, so you want white to be 0. And everyone else to be 1. Okay. Yeah. So and then once you finish that, you just select all of that and press the play button. Help? Help? Anyone need help? 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 On the old and the new, you got to make sure you have the same numbers. Help? Help? You got it? Oh, good. Okay. Help? 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 Yep.
In the end, we have sent you the log and the frequency, right?
Mm-hmm. So just if you save, hit the little, yeah, and then so call it class 2.
Oh, okay.
Like, and you'll put it wherever you want to put it, and then name it. You can put your names in the data file, and then I forgot to put a place on OBA, so you can just email it to me.
Are you familiar with Apple?
Not really.
We don't know how to delete other things we...
Oh, that you don't want me to see? Okay, so all you have to do is do like that if you don't want me to see it. So let me go back up so you can kind of see what I just did.
Just hide it.
Yeah, so that hides it, yeah.
Okay, thank you.
Mm-hmm. Still working or good? 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 Thumbs up? Thumbs up? Good? Almost done? All right. Thumbs up? Good? That's all right. Oh, you only have to do it once. Right? Because you only need to create one variable.
But then why did we do it? Yeah, why did we do it twice then?
Oh, because I want you to create one dummy variable where it's everybody who's white compared to everybody else. But I want the whites to be the reference group. So if you get rid of that.
This?
Yep. So which are the whites?
4.
Okay, so everyone else should be recoded to 1.
Oh, everybody.
Mm-hmm. And then you got to think of what you want to call this group now that you're indicating.
Not white.
Yeah, right? I mean, it's kind of how it's defined.
Do you know why? Because my SPSS goes with internet, and I don't have internet.
Oh, poo. All right. Yeah, I don't know what's going on today. The signal's really terrible, so sorry. Well, if you want to, like, move this way and then, like, get on the other side of Dan or work with Craig or something.
Original variables, or just those
Sorry?
three? Is gender considered one of the original, or just the three that we
Just
were
the 3 that you did for lab is fine.
So how do you set, on his computer, it's not set to put the log,
To do what?
I don't have logs in my output.
The logs, I need
Oh, so if you go to File,
Log or syntax?
go Options. Is there no options? What about, hold on, File. Oh, there it is. And then Viewer. Yeah. Oh. Say apply. And it will from now on. It's okay. Just send me. That's okay. Sure.
Where do I find the log? 'Cause I had that already set.
Yep. Okay. So then go to your output file, and go up a little bit. There it was. Oops, slow down. There it is.
I can do that. Okay. So, was there a form on Openverse that we're filling out?
Yeah,
We
I
can make
forgot to
Word
put it
document?
there. Just now, you can just email me this file.
The output file?
Yeah. Okay. Hello. So I know that a few people are still wrapping up. So I just want to kind of share something because I think some of you aren't having your syntax produced with your output. SPSS changes. I think the default used to be that it assumed you wanted it, and now it assumes you don't. So if your syntax is not showing up, then you want to go to Edit, Options, and then to Viewer, and you want to make sure that this little box down here is checked, Display Commands in the Log. And that's what will give you a syntax record of everything you've run. And it's handy to have because if you ever are running an analysis and you make like one little mistake, like say you recoded something wrong and oh my God, now I have to go through all those boxes again, are you kidding me? No, you can actually copy and paste the commands and put them into a syntax file, which I'll show you in a second, and then just say play and it'll boom, run through all of it in one fell swoop. So I'm just going to say OK here. And just to show you what a syntax file looks like, I'm going to do File, New, Syntax. And this is what it looks like. Okay? So if I want to pull in syntax from something I've already done, I can just go here. I haven't done anything in this particular file, but what the heck. I'm just going to, I selected the text. I pressed Control Copy, just like in a Word document. And then I just do Control V to paste, just like a Word document. Okay? So, and some of you started playing with syntax already, because if you do make a mistake recoding things, it's a real pain to go through all those windows again and again and again. And so as you become more comfortable with SPSS, you may find that you almost prefer to do this. And the last thing that I'll show you is, so let's say I'm recoding something into a different variable. I don't know, let's say I'm doing type of program since we haven't done that one. And I don't even remember what that stands for, so we'll call it junk. Junky junk. And it's even spelled wrong. And so I'll make my ones, I'll copy those old values, and all my other values I'm going to make a 0 because I don't know what they stand for anyway, and say continue. All of this was just to show you, instead of saying OK, if you press paste, it goes to your syntax. And so it's a little hard to see here because I didn't put a space in there, but this is the syntax for all those little clicks I just did. So then I can just copy and paste it and change the variable name and so on. Okay? All right. I'm going to just close that up. No, I don't want to save it. It's junk. Okay, and also when you paste, instead of saying okay, it doesn't actually run it. So if I wanted to run and create that variable, I should have not closed it quite so fast. Select what I want to run, and then press, there's like a little play button, a little green play button. If you just hit that, it'll run whatever is highlighted. If you want to run everything there is, you do Control A, just like in Words. It's selecting everything, and then you press the play button. Okay? All right, so questions about what we just did? So how many of you created more than one race variable? Good. Okay. I thought we caught everybody who was doing more than one, but I just wanted to make sure. Okay, so great. And everybody figured out for SES that in order to compare low SES and high SES to middle SES, you needed two variables. And one was low SES, where low SES got a 1 and everybody else got a 0. So like the reference category there is kind of like not low SES. It's only once we put this into a regression equation that we're magically going to get the comparison to middle, because they're going to be the only one who has a 0 on both of those SES variables. Okay. So another way to check on your work, and you can follow along if you want to, or just look at the slides themselves, is to run the frequencies just for the original variables, but then to actually run your correlations with descriptive statistics for the new variables. Why would I do that? Because I'm killing two birds with one stone. I can still check to see if I've recoded correctly, but then I'm also getting to know my data. So, if you are following along, pull in the achievement test scores as well, because we're going to want to look at what all this looks like together. So on the left are the frequency tables for my old variables, and on the right is the descriptive statistics table for my new variables. Now, one of the beauties of dummy coding is if I had tried to run descriptive statistics on something like SES, I would have got a really crazy mean, right? Because I had values of 1, 2, and 3, and so it probably would have been around 2. Actually, 2 weighted towards 3, like 2 point something. And so that becomes really difficult to interpret. When you have a dummy coded variable, what you get is the proportion of individuals who have that characteristic as your mean. So male students, I can say, oh, I had a proportion of 0.455, and that matches the percent up there for males. So it's a different way of making the same check that we were doing a minute ago. I can do the same thing. I created a variable called non-white, for lack of a better term. And they represented 27.5% of the sample. Here I have to subtract 72.5 from 100 to get that magic number. It matches the proportion. Good to go. Question on that one? Good. For SES, what I need to do is compare the two new variables to the original one. I have 0.235 for the proportion, 23.5 for the percent. Everything's matching up nicely. High works as well, 29%. And then finally, private school, 16% of the kids were going to private schools, and my proportion is 0.16. So I successfully recoded all my variables, and I've got the means for the different achievement scores. Note, the N is the same for everything here, okay? This, because it was a large federal study, when they, well, I don't know if the data for this teaching data set actually was selected for not having missing values or if they imputed. We don't know because we inherited the data, but the beauty here is we're not going to have to pay attention to list-wise or pairwise deletion at all. Yay. So, and then, rather than show you the big correlations table that's spit out, I thought I would show you what a a table that summarizes all that information we just saw a minute ago, the means and standard deviations, as well as the correlations, looks like an APA. And we're going to be posting templates of things that you see in the slides so that you can reproduce things like this when you're working with APA format in your papers. One thing to just pay attention to, you probably can't tell because you don't have an eagle eye, but this is not actually using decimal alignment because PowerPoint doesn't let you do it in a table. I don't know why. So I did a little trickery to make things look as closely to decimal aligned as possible. If you don't know what decimal alignment is, please come to office hours. It's not an easy thing to explain on email. That said, there are so many excellent YouTube videos on this stuff too that you might just try Googling decimal alignment word or something like that, and you probably get something that teaches you it really quickly. So what do we notice here? So first of all, I've got a list of variables, and because I've numbered them, I don't have to spell them out as I go across the title row, so it saves me some space. APA abhors redundancy, so anytime we can save some space on a page, APA editors are happy. So M is my mean, SD is my standard deviation. That's just reproducing, hopefully accurately, the information from the previous slide. And then the correlations start. So rather than doing what SPSS does, which is to put the same thing above the diagonal as below it, I've just put each correlation once. And generally speaking, for whatever reason, people prefer to do it this way rather than the triangle that would go the other way. And instead of putting correlations of 1.0, the convention is to put an n dash, or yeah, I think that's an n dash. And that way, because saying that something is perfectly correlated with itself is just not interesting. So again, we try to save on ink. Okay, what else can I tell you about this table? Let's look at the correlations. I'd like to just hear what a few people notice. Nothing? There's not a right or a wrong answer. I'm just asking for some interpretations. Eva?
The private school variable doesn't seem like it's super strongly associated with a lot of the other variables.
Ah, good. So she's looking at private school, this row, and saying, look at those numbers. They're not significant. Actually, I should have started here. There's no significance there. But to see the rest of the relationships, I do have to find 7 in the column and follow it down. So you're right, there really aren't significant relationships. The only thing that even gets into significance is the relationship between private school and low SES. And is that relationship strong? No, it's pretty weak. Okay? Good. What else do people notice? Where are all the strong correlations here? Among all the achievement scores, right? They're much more strongly related to each other than they are to almost any of our predictor variables, okay? So basically, we want to look at this stuff going in so that we have a fairly, at least a passing sense of what our data should look like. We can also note that the mean score is around 50, so this is probably a standardized achievement test where the mean is generally 50. And our standard deviations hover right around 10. So that's going to help us to kind of interpret whether effects are big or small relative to the scale of an outcome. Note in the note that I explained that these are proportions, that they're not like actual values of high SES or something. And I also put a key for my p-values. Okay, so I know that not everyone in the room has been forced to use APA. I will consider allowing you to use other editorial systems, but you've got to be really solid on them and let me know what you're using. Okay? Okay. So now we are ready to do a little ANOVA and multiple regression. And I think what I'll do is I'll get through this topic and then we'll have our break. Okay? So over the rest of the evening, we're going to answer these 3 research questions. And we're going to be doing this again with the high school and beyond data set. So to what extent does school type predict reading achievement for high school sophomores? Okay, so I've put in bold here what our IV is. Our DV is always going to be reading achievement. Our population is always high school sophomores. The second question asks about SES. And the third asks about whether the effect of SES depends on school type. In ANOVA, how would I know that? Do I just compare the two? All right, that's all right. It might be too early to ask that question. It'll come back to you as soon as you see it, I trust. Trust me. Okay, so right away, let's answer the first research question, okay, about school type. This was the school type variable. We're going to use our private recoded dummy here when we do the regression, but for the ANOVA really doesn't care what form of the variable I use because it doesn't treat numbers as numbers, it treats them all as categories when they're IVs. So I'm going to say analyze general linear model univariate, okay? And that will open up the window that you see on the left. I'd prefer that you use the categorical version of the variable because it'll help me illustrate why we recode things the way we do. So we're going to put the read variable in for our dependent variable and the type of school type, the original variable, in as a fixed factor. We can also click the options button here and ask for means by school type, estimated means by school type, and almost put that over this, we want to request parameter estimates. In fact, I think I have something else checked there, so I'm going to move that for a second. Yep, there we go. Okay, so you want to check off descriptive statistics, estimates of effect size, and parameter estimates. So once you've done that, here are some of the things that SPSS spits out. I'm not going to take you through a detailed analysis of all the different tables because you should be fairly familiar with them already. I will just direct your eyes to school type, the effect of school type here. And is it significant? No. And the partial eta squared, our estimate of effect size or variance explained, is 0.007, not very big at all. Then the estimated marginal means, you'll notice I get actual estimates for public schools versus private schools. This parameter estimates table is what mimics what multiple regression does. And this is why we actually don't need, if we have 2 levels to a variable, to have 2 dummy variables, because what would happen if we tried to put them both in is SPSS would spit one out. Because in a multiple regression, the intercept is the not included category. So what happens when you do this using ANOVA is that SPSS just decides who it's going to boot out, okay? And it's usually the higher category. So I end up with my intercept representing private schools, and my public schools, to get this estimate, I have to use that beta estimate and add it to the intercept. So if I do 54.25 plus negative 2.405, drum roll please, I come up with 51.845. Okay? So the estimated means table is just telling me what I would get if I wrote out the regression equation here as SPSS spat it out. Okay? Now the problem is that we wanted to see what the effect of private school was, right? And SPSS has sort of by default made it the reference group. So in order to really get at that, the truth is the ANOVA table is telling me, well, that's not a significant effect. But if I want a table, a regression table that makes that a little bit more clear, then I'm going to need to take a different approach. Oh, I stole my own thunder. There you go. So how did I know which group it made the comparison group or the reference group? By looking at what the intercept was. Okay? Okay. So for the multiple regression approach, I'm going to go in, analyze regression linear. Okay? And this should look pretty similar. I'm going to pull in reading score as my DV, private school as my IV. Now this is the new version that we created, so it's the private variable. Make sure you're using the dummy version. And don't forget to hit that statistics button and request all of that good stuff that we normally request when we're running our regressions. And once we do it once, it'll remember it from here on out. Okay? So when you're done with that, you can click Continue on the statistics window and OK on the linear regression. And here's what you get. So first of all, here's my ANOVA table. Okay, this is identical, pretty identical to what we saw for the ANOVA. The numbers match, just not all the numbers are there. Notice the significance value is exactly the same. So is the R square, which is the equivalent of eta square here. And finally, here I get the right reference group. I get my public schools for my intercept or constant and private schools for my slope. And I come to the same conclusion that they're not significant. Oh, and which group did we make the comparison group? Public schools. How do we know? Because we named the slope so meaningfully, right? So it's the effect of private schools. Okay. So rather than try to put the results from all of this on the same slide because the print gets really small, if you go back and forth between those results, what you'll find is that school type was not significant in either model. And my p-values are exactly the same. My variance explained is exactly the same. It's just that ANOVA calls it eta squared and regression calls it R squared. My coefficients are different, right? But, and the slopes are kind of the flip side of each other, but when I actually calculate estimates for private schools and public schools, lo and behold, they're exactly the same. Okay? So I can do with regression what I was doing with ANOVA. And the nice thing about that is going to be that we're going to be able to use continuous as well as categorical predictors moving forward. Not everything in life is easily categorized. Some of it's continuous. Okay, so let's take our break now. Okay, so like 20 minutes. We'll come back together about 10 after. Okay.